Hello, am I audible? Hello, hello. Okay, fine. So voice is clear to everyone, I hope. So let's start. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. And till now, we have completed the complete first portion of magnetism, that is moving charges and its magnetic effects. If I will summarize the complete topic, what we have studied in that chapter, that if some magnetic charge is flowing, that means due to that, what will happen? Current will be flowing. If some current is flowing, due to that, some magnetic field will also be induced around that. Okay. So what we are going to study in this chapter, electromagnetic induction, just the reverse process that we are going to understand here. What we will be doing here in this chapter, firstly what we will do, we will create some magnetic field. We will be changing some parameters, magnetic field area, and due to all these things that we are changing, net actually will be changing the flux. I will be telling you now, due to some magnetic field, there will be some current that will be induced into the circuit, into the loop, whatever you will be connected, and there will be some, if there is some current, there is some potential difference or some EMF is also generated, and that is what exactly this chapter is all about, electromagnetic induction. That means this chapter will be telling you about how this current is induced, how this battery or EMF that is induced. All these things we'll be discussing in this chapter. If I will telling you, it is a good weighted chapter from all the perspective. Okay, from the competitive exam it is more important because it have good decent amount of formulas as well for calculation purpose. But first time we understand about inductors also in this chapter. Yes, we are going to see about inductors. We are going to study about two very important laws. One is Faraday's laws and second one is Lenz's law. Okay, because without Lenz's law you cannot understand Faraday's laws. I will tell you why I am saying like that. So further, without wasting any time, let's begin. Be ready to learn something new with your pen and paper. I hope that you are ready. So let's start without wasting any further time. Okay, see what you are going to study in this thing, in this chapter. I have already told you that initially we were studying what, that change in current or current will induce some magnetic field, but now we are going to do, we are going to change the magnetic field, and due to then some electric or current will be flowing into the circuit. This is what we are going to understand. Okay, here is a setup that Faraday did some experiments, and from his experiments he have concluded something. That is what this chapter is all about. This chapter will be completely rotating around the Faraday's laws, because that is the base of this chapter. Okay, but before understanding Faraday's law, firstly you have to understand what is magnetic flux. Tell me, what is flux? In general, I have told you in electrostatics, flux is any kind of quantity that is crossing through a cross section area. So here what is the crossing thing, or what is crossing actually? Here it is crossing magnetic field lines. In electrostatics, electric flux was what? Number of electric lines of forces that was crossing a cross section area, that was defined. Fluid mechanics also, what is flux? The rate of flow is defined as flux. How much water is crossing through some cross section area, that was defined as flux. So here what we are going to define. Let's suppose I have taken some cross section area, and how many number of electric lines of magnetic lines of forces, magnetic line of fields actually are passing, that is defined as flux. And about flux is actually, when it was calculated, flux was defined as, flux was directly proportional to B, and flux was directly proportional to the area. Flux was coming directly proportional to area, and when I have changed this angle, this was the area vector, this is the direction for magnetic field. If I have changed this angle, this flux was also coming directly proportional to cos of theta. So if I am combining all these three, what I can say, flux is equals to BA cos of theta. So what I am understanding from here, students, flux is equals to BA cos theta can also be written as simply as B dot A. Flux is written as B dot A. That means if there is a dot product, that means the resultant is going to be a scalar quantity. This is going to be a scalar quantity. Correct? because without flux we cannot understand Faraday's law. This complete chapter is going to use the Faraday's law. Okay, so see here what is written here. B dot A is nothing but equals to B A cos of theta, and SI unit what we define for flux is Weber. Weber is what? Magnetic field, that is Tesla meter square, it will be called as Weber. And finally the final result that we define is phi is equals to integration of B dot dA cos of theta. If there is some integration variable kind of question is coming, then we'll be writing this general equation. Okay, so now let's come to Faraday's law. Let's come to Faraday's law. Three things that Faraday's have noticed. I am going to tell you all the experiments one by one. Firstly, what he have did, he have placed a loop into a time varying magnetic field. Time varying magnetic field means what, students? A field that is varying with time, that is changing with time. That is represented very beautifully here, that it is kept in some magnetic field that is varying with time, that is a function of time. And what he have observed, he have observed that now some current got induced into the circuit. Now it will be in anti-clockwise direction or clockwise direction. That is a separate thing that we are going to understand by Lenz's law in complete depth. But here what I am telling you, some current got induced, correct? And if there is some current, I can say some EMF is also there, correct? Because without, it is an imaginary EMF. So he said that some current got induced. Okay, some current got induced, and of course if some current, there is some EMF as well. So it was completely surprising. Why? Because it was the first time with that, without applying any battery, without doing anything, just keeping in magnetic, first time current was flowing into the circuit all of a sudden, correct? So this was the first observation that Faraday's have made. What first thing what you are changing? Remember this thing, magnetic field. Okay, now what he have did, he have changed this area with respect to time. What he have did, he have changed this area. Initially the area that he was taken, and then he reduced this area. When he changed this area, again he have observed that some current started flowing into this loop. Again, to changing in area, some current got induced into the loop. Okay, wait a minute. Okay, this cell में ना carbohydrate present है. गेट लगाओ. Okay, so due to changing in area, again some current got induced into the loop, correct? This was the second observations. Now what was the next observation? He started rotating this loop with some angular velocity omega. He started rotating this loop with some angular velocity omega. And then he have observed, due to this rotation, the angle between the magnetic field of I will tell you, if in 3D, let's suppose this is a loop. Initially, let's suppose this is the area vector perpendicular to it, and the same direction is for magnetic field. Initially angle was same, but now I have started rotating it. Now it is facing towards you. That means area vector is towards you, magnetic field is still this direction. That means, can you say now it is changing angle at every single point? With time only it is changing. That means with time what is happening? Angle is also changing. That means the third case what is happening? Again he have observed, when you started changing the angle, that some current got induced into it. Some current got induced into it. So he have concluded one thing. Initially what was changing? Initially current got induced due to change in magnetic field. Then what happened? Then current got induced into change in area. And then what you have observed, when you have changed this angle theta, again some current got induced. When he combined all these things, then we have said that actually this current and this EMF that is getting induced is due to the change in flux, because flux is nothing but what? BA cos theta. Once you are changing this magnetic field, still some current is coming. If you are changing this area, still some current is coming. If you are changing this angle theta, still some current is being induced. That means by combining all these things, I can say that by changing the flux, some current got induced, some current got induced. That means some EMF is also induced into the loop. Clear? Correct. So now let's combine the law, and the two major statements that was given by Faraday is given here. Read what are the statements. Whenever there is a change in magnetic flux, whenever there will be change in magnetic flux, An EMF is induced in a conductor, and if it is a closed circuit, induced current will also follow through it. If there is some change in the flux with time, there will be of course some EMF that will be induced into the loop, and if some EMF is getting induced into the loop, if it is a closed circuit, that means some induced current is also mandatory to flow into that loop. This was the first and very important thing that was given by all the experiments that he have did previously. Second thing, Faraday's second law. In this second law, he have told you about the magnitude. What was the magnitude? The magnitude of induced EMF in a conducting coil is proportional to the rate at which magnetic flux through that coil is changing with time. Simple term, if I will tell you, the EMF that is induced, EMF that is getting induced, it is equals to mod of d phi by dt. What is this d phi by dt? Rate of change of flux. EMF was defined as d phi by dt, and this is a very important result. Actually, there is a negative sign as well. I will tell you why that negative sign is also coming by understanding Lenz's law. So the question that will be coming to your mind, okay, till now it is clear that okay, it is induced, very good, it is induced. Okay, current is also induced. But if I will ask you, tell me, either it will be induced in clockwise direction or either it will be induced in anti-clockwise direction. What will you say about the directions? Faraday was not explained the direction. What will be the direction of induction? That's why we studied the second law, that is Lenz's law. Without studying Lenz's law, you cannot understand Faraday's law completely. It will tell you about the magnitude also. It will tell you why this EMF is induced, but it will not tell you about the direction. Either it will be clockwise direction, either it will be anti-clockwise direction. I hope this will be clear to you. So let's understand about the direction portion. Okay. Firstly, this is the basic definitions that you will be having. EMF induced is equal to, I have already told you, d phi by dt or delta phi by delta t if you are taking a long time period. Average EMF, that means average is taken for a long time period, and if n number of turns are there into that loop, like here you are taking some n number of turns here, so multiply simply the flux by n number of turns. What you will say? Average EMF equals to n into delta phi divided by delta t. You know that from the motion in 1D that if you are taking for a longer time period, we use a delta. If you are taking for instantaneous thing, just differentiate this. Whatever the equation will be given, just differentiate that equation. You will be having your instantaneous EMF. You will have your instantaneous EMF. Just multiply it by number of turns. Again, I will say you will be having the value. Correct? So if I'll ask you current also, how will be writing current? Current will be simply written as EMF divided by R. That means whatever the EMF that you are having, just divide by R. If I will ask you, tell me what is the average current, I will be writing average current will be written as this complete term and delta phi by delta t divided by R. If I will ask you what is the instantaneous current, what will be written? d phi by dt multiplied by n number of turns divided by the resistance, what will be coming with the EMF. Just do it. You will be having an answer. Correct? Exactly the same thing, just divide by resistance, you will be having your results. Clear? These are the some basic things that you can say. One more very important thing that I will tell you. What is current? Current is equals to delta q by delta t. So if you have to write dq, how will you be writing? Dq can be written as, what happened this? There is some technical glitch. What is happening here? Where the pen went? I think this will be working. Okay, fine, no problem. We'll be taking this pen. Okay, so let's discuss what we are discussing. So if I have to ask you, tell me what is dq you will be writing. Dq you will be writing is equals to I into dt. Dq you will be writing is equals to I into dt. And how you are writing I? Current. Tell me how you are writing current. Current delta phi divided by delta t divided by the resistance, that is R. Correct? Now dq you will be writing, this will be the what, current multiplied by dt. So can you say dt will simply get cancel out, and how you will be writing delta q? Delta q can be written as, it is a very important result that you have to remember, it is equals to delta phi divided by r, and if n number of turns are there, multiplied by n. What is the total charge flown? For that thing you have to write, use this formula directly. It is the formula delta q is equals to n into delta phi divided by the resistance. Just do, that's it. This will give you the result, how much charge that is flown. Okay, so it is a very important result. Sometimes direct questions are coming from here. Okay, now this is a basic question, try to solve it. Our proper pen is not coming. Wait, I will restart this. Just give me 2 minutes. I know that it is, you all enjoy the breaks. I know that it is. Okay, our voice is also perfect. Don't you enjoy when teachers give you all of a sudden unexpected breaks? Here the students that I teach them, they enjoy, they love it. They always find some ways how we can get some break or these kind of things. Tell me in the comment section how your preparations are going on, because I guess from tomorrow there is boards exam also, I guess for 10th boards. Let's see, I hope that this time it will be fine, because without this pen I don't enjoy. Electromagnetic induction. Let's see, this time it's help us for how much time? I need, it takes a lot of, this system is also getting slow. Where we were, क्या पढ़ रहे थे हम लोग? We have seen, we were in the question. Cool. We were in the question. This is the actual pen that you are looking at. Sometime it got disappear, and I like this pen. Okay, let's keep it here only. Perfect. Now read the question. What is the question? A coil of resistance 400 ohm. What is the resistance? Now what happened? Again it gone. What is happening here? Why it is not functioning properly? Sorry for the glitch, students. Read the question. Now we will see after some time. A coil of resistance 400 ohm is placed in a magnetic field. If the magnetic flux phi is linked with the coil that is moving, this is the flux that they have given, that is the resistance. You have to calculate what is the current in the coil at t is equals to 2 seconds, right? Firstly, all the given things. Fine. Write all the given things. What are the given things? Resistance is given as 400 ohm, correct? Flux is given as 50 t square plus of 4. Now what they are asking you, they are asking you about current at t is equals to 2 seconds. They are asking you for current that is at t is equals to 2 seconds. So what I can do, I know that firstly, can I calculate what will be the EMF that will be induced? EMF, what is EMF? EMF is nothing but equals to d phi by dt. Simply differentiate it, you will have your EMF. Now how to differentiate it? I guess all of you students will be knowing how to differentiate. What will the differentiation? Tell me. Differentiation will be 100 t and the differentiation of 4 will be equals to 0. Now put EMF will be at t is equals to 0 will be how much? put T is equals to 2, that means it will become 200 volt. If EMF is equals to 200 volt, what will be the current? Current will be EMF divided by resistance. EMF is 200 divided by resistance, that is equals to 400. Answer will be 0.5 ampere. 0.5 ampere. Which option is coming correct? A option is coming correct. Is it clear how we have solved? I hope this will be clear to you. Correct. Option A is correct. Let's do power off and power on. Let's hope that now if this time I will take this out. Still nothing is happening. Don't know, due to some reason it is hanging. Okay, finally we came out. Here. Wait a minute. आज लगता है बोर्ड पढ़ाने नहीं देगा. Here it is, creative sketch art. Hi. Okay, fine. Again it get opened and hopefully this time it will be working fine. I hope that this time it will be working fine. Where about physics? Opening electromagnetic theory. Till here Pain is with us. We have solved that question and we had to start Lenz's law. Correct? Let's begin. Please pray, students, this time the glitch will not be happening. Okay, otherwise it creates a lot of problem. Fine, thankfully touch wood. So let's restart. The polarity of the induced EMF is such that the induced EMF that it will be generated the induced EMF that it will be created, it will generate itself, it will induce itself in such a way that it will always oppose the cause. It will always oppose the cause. For the next 10 to 15 minutes I am going to explain you only what is this cause, what is this oppose, and how this is getting induced. Only this much of the things. Once you understand the soul of this concept, then rest of the chapters is just basis, or it is on the basis of this, that there is nothing special that is you can't understand. You have to understand what about the direction. And if I will tell you, direct questions are coming just on the directions from this chapter, that if some magnet is coming closer, what will be happening, if magnet is going away, then what will be happening. All these things we are going to discuss here. Okay, so let's see one by one. Lenz's law, the statement is very clear. Lenz's law states that the polarity of the induced EMF such that it tends to produce a current. Actually it is creating lag. There is no benefit. Fine, let's continue with this pen only. Okay, the polarity of induced EMF, the current is induced in such a way that it always opposes the cause. Now if we will see the formula also, E is equals to what? Minus of N d phi by dt. Now see, I will say what it is very beautifully explained. This is what the effect that is coming. This is what negative sign always represents the oppose. And this is what the cause. who is causing actually this induced EMF and induced current. It will always try to, who have wake me up, I will kill them. It is like that kind of character, if you can relate. So this is the cause. Flux, magnetic flux is the cause who have generated this sleeping current and induced EMF, and it will generate in such a way that it is going to oppose that cause, correct? So it will not be clear from this only, you have to see lot of examples. So now let's understand from some examples. Okay, see here, understand. If you are clear about the directions, I will tell you that how magnetic field is induced. Magnetic field, for finding the direction of magnetic field, you have to curl your hand in the direction, you have to curl your fingers in the direction of magnetic field. If someone is having doubt in how to find the directions, you have to go through the lectures of the last chapter. Okay, now see here what is happening. A magnet is coming closer to you, a magnet is coming closer to the loop. Okay, a magnet is coming closer to the loop. Due to that, what will happening? Due to that, what will happen? I will say, due to this closer coming magnetic field, magnetic field will be increasing. Magnetic field will be increasing. If with time magnetic field is increasing, what I can say, flux is also increasing. Flux is also increasing. If flux is increasing, can you say some current will get induced into this? Some current will get induced into it. And how that current will get induced into it? Current will induce in such a way that it is going to oppose. Now see how you will be opposing it. That is the actual concept that you have to understand. I will say magnetic field was increasing, and due to this increase in magnetic field, are you agree till here? Are you agree or not that it increase in magnetic field will create some current? It will create some EMF also. So now you have to oppose it. How you will be opposing? Now you will be having some induced current. And if you are having some induced current, if you are inducing in such a way anti-clockwise direction, that means what is the direction of induced magnetic field that you are inducing? Because due to some current, magnetic field also get induced. So you will be inducing a magnetic field that is in opposite direction. That means you will induce a magnetic field in opposite direction. So can you say now you are opposing it? In this direction, magnetic field was increasing. In this direction, magnetic field was increasing, and due to this increase in magnetic field, current got induced, and this current got induced in such a way, it got induced in such a way that now it is what doing? It is decreasing this magnetic field. It is trying to decrease this cause who have generated it. That means it is trying to decrease the magnetic field. Is it clear? Not clear? Let's understand one more example. I will make you understand what is this cause and everything. See here, just understand, be with me. Here what you'll say, see, here you will say that this is the direction of magnet, but what is happening, north pole is towards this and south pole is towards this. That means I can say this time magnetic field is what? Decreasing. Magnetic field is what? Decreasing. If magnetic field is decreasing, in which direction? In which direction magnetic field is decreasing? In this direction magnetic field is decreasing. If in this direction magnetic field is decreasing, due to decrease in magnetic field, I can say flux is also decreasing. If flux is decreasing, that means what I can say, some current will also get induced. That means it will now induce thing will be try to do what? It will again try to oppose it. That means what it will try to do? It will try to increase this magnetic field in the negative direction. It will, the induced current will try to the induced current will be trying to increase the magnetic field in the negative direction. For that, what kind of circuit, what kind of induced current you have to generate? You have to generate a clockwise direction current. Due to clockwise direction, the induced magnetic field will be coming in the negative direction. The induced magnetic field will be coming in the negative direction, and hence you can say it is induced into clockwise direction. Now these third and the fourth answers are given. You analyze it and then tell me in the comment section. This is the homework thing that I am giving you, that how these are justified, and you comment down your answers in the comment section. Okay, now see, more simpler here. Again we are just going to judge the directions only, nothing special. Here see, case 1, increase of magnetic field in inward direction. In inward direction magnetic field is there and it is increasing. Magnetic field is increasing in inward direction with time. That means there will be some current will induce, correct? This you agree. Now what the question will be, the current will be induced in clockwise direction or anti-clockwise direction? So the answer is the current will induced in such a way, the current will induce in such a way that it will try to decrease this magnetic field in inward direction. It will try to decrease the magnetic field in inward direction. How it can try to decrease the magnetic field? It can induce a magnetic field in outward direction. If one vector is in inside, one vector is in outside, so can you say the magnitude wise it is decreasing? So I will say the current will induce in such a way that in outward direction it is decreasing it will induce a magnetic field, and now I can say it is going to net, if I am talking about it will try to decrease the magnetic field, net magnetic field who is induce it. Correct. Now let's see one more example. Case 2. Case 2 is what saying? What case 2 is saying? That increase of magnetic field in outward direction. Now there is dots is representing what? That magnetic field is coming in outward direction and it is increasing with time. If magnetic field is increasing with time, then what will be happening? How it will be generated? This increase in magnetic field, it is sure that it is going to generate some current also. It is going to induce some current also. Now this induce current will be trying to do what? If this is increasing in outward direction, it will try to decrease this magnetic field in outward direction. Now how you can decrease? That means you have to induce a magnetic field in the inward direction, then only you can decrease. How you will be inducing? If you are going in this direction, what I can say, what is the direction of the magnetic field, induced magnetic field that you are getting? Induced magnetic field direction that you are getting is inside the board. You are getting, that is equals to inside the board. If you are getting the direction inside the board, one is coming outside, one is going inside, of course you are going to decrease the magnetic field. That means what it is doing, it is always trying to oppose the cause. It is always trying to oppose the cause. Correct. Now here, next case, current carrying wire and coil system is given. Now what is happening here? What is represented? Understand here what is given here. See here, current is increasing. So what will be happening, sir? Due to current, what will be happening? Current in this wire is increasing. You remember what is the magnetic field that is experienced last chapter? The magnetic field is equals to mu naught I divided by 2 pi r. So I can say if current is increasing, what I can say? Can I say magnetic field is increasing again? That means in this complete area magnetic field is increasing. Due to this increase in magnetic field, I can say some current will induce and some EMF is also induced. If you got the direction of current, that means of course you can have the direction of EMF as well. If this EMF is induced, some current is got induced, what will say? What this current is going to try? This current is going to try to decrease this magnetic field. In which direction? In inward direction. How you will be decreasing that? You have to induce a magnetic field vector in outward direction. Check, if you are inducing a current in this direction, what is the induced magnetic field is coming? Induced magnetic field is coming in the outward direction. This is the direction for current that is got induced. Is it clear? Are you having familiar with it? Let's see one more case. We'll understand. Without understanding, we are not going anywhere. See what we are doing. A current constant, now this time current is constant, but we are taking this loop away from here. We are taking this loop away from here with some velocity, constant velocity v. Okay. Due to that, what will be happening? Again, remember what was the formula that I have told you? That is, it is equals to mu naught I divided by 2 pi d. So can you say now this distance is increasing from this wire? Correct now? If this distance is increasing, what is the magnetic field is decreasing. If the distance is increasing, that means magnetic field is decreasing. If magnetic field is decreasing in inside direction, that means what this is going to do? What this is going to do with this is going to induce some current and EMF as well. And what this induced current is going to try to do? This is going to try to increase this magnetic field in inside direction. This is going to try to increase the magnetic field in inside direction. How you will be increasing the magnetic field? You will be increasing the magnetic field by a very simple method. You will be inducing a current in the anti-clockwise direction. That means you are having a induced magnetic field in the inside direction, and that current will be helping you to find it will be satisfying the Lenz's law. Now what you are doing, you have induced a magnetic field in the inside direction. That means you are doing what? You are again opposing the cause. We have generated it, decrease in magnetic field. What you are doing, you are induced in such a way that now you are increasing the magnetic field in the inside direction. That means what? The cause that have generated you Now you are the current, you are opposing that cause. That means why magnetic field is decreasing, I will not allow this magnetic field to decrease. I will try to maintain that, either I will try to increase that. I am just going to oppose it any way possible. Is it clear? Interesting. Lenz's law. See, now what is happening? Now the current is also constant, this loop is also constant, then no motion in this loop also. So what I can say from here, that if current is also constant, there is no change in angle and no flux is changing, so why I will induce? There is no reason for induction. So if there is no reason for induction, no current will be induced, no induced magnetic field, nothing, EMF will also be coming. Clear? So Lenz's law statement says of conservation of energy, actually it is based on conservation of energy. EMF generated in a coil will always try to resist the change in magnetic flux. The mechanical energy spent on the relative motion between the magnet and the coil gets converted into the electrical energy. The EMF that is generated, or the current that is generated, is actually the conversion for the relative motion between the magnet is gets converted into electrical. The mechanical energy that you have created due to this relative motion, okay, because obviously there will be some potential and kinetic energy, that total mechanical energy that you have created is now getting converted into electrical energy, and that is why we are watching this EMF as well, correct? And hence Lenz's law is based on the conservation of energy. Now motional EMF we are going to take from the next lecture. So until next time, I keep learning, keep growing with tapasya, endigu and then digu namma tapasya.